Welcome to today's video. My name is John Kim. This is the GDTOLOGY Channel, and today's topic is CMM software and its relationship with Gd&T. Now, in design, we all use, most companies use Gd&T to make sure that they communicate their design intent into the design properly. And when it's inspected, that it is inspected per the dimensional tolerances that are either on the drawing or on the model. Now, the thing is that, in most cases, a lot of places, they use CMM software. You got your big names like a PCDMIS, you got Polyworks, you got Veriserve, and you got all these other CMM softwares used for inspection. Now the thing is that what I've seen in the past is that you'll have a physical part that needs to be inspected. They'll be sent off to either a CMM house, or sometimes your customer or your vendor will do the inspection for you. And what I've seen in the past is that somehow there's a huge disconnect between the engineering intent and the actual inspection. And what I've seen in most cases is that the engineering side, they understand Gd&T. However, the inspection side, in most cases, they're kind of sort of clueless in a sense. They say like, oh yeah, well, we know Gd&T as well. And the thing is that when I've seen them run through the inspections, I've seen a huge disconnect. There's a term what they call best fit. It's when you have all these data points, basically you do a best fit line through it. I forgot, it's in our statistical class, or we've used in our science classes before. They'll perform, this best fit alignment, and what that does, that's really just sort of like an approximation. When you guys are using CMM software, you have this point cloud data. Typically a probe will touch the part and create all these data points, and the name of the game is really to align these point clouds to certain data features so that it does, represent the true design intent of the part. Now, for people that are not experienced in Gd&T but have worked CMM in the past or as a career, I've seen a lot of mistakes happen where they'll just take the part and they'll do a best fit and they'll say, oh, this part is good. The problem with using best fit is that there's no order of precedence to certain data features. The thing is that, okay, well, the report will show good, but when the actual part is in your hand, sometimes it doesn't bolt together. Okay, these parts don't fit, even though the CMM, the report says everything is good. So what I'm really saying is that I've seen a lot of disconnect, and we really need to get design, engineering, and the CMM side of the industry all together as one. Because right now, I've seen a huge disconnect, and I've seen it day in and day out. Like I said, the engineering intent was one thing. The inspector will inspect it using another method, and basically that doesn't represent the true engineering intent. Now, I'm not saying that all CMM houses are bad. Some actually are really good and they really know what they're doing. But in most cases, I've seen, they'll just toss away, some of these geometric tolerances. They won't take the actual mating envelope of the part. What does that mean? That just means that, let's say you have a hole, you want to find out what the positional tolerance is. Remember, the actual mating envelope would be as if you took a gauge pin, the biggest gauge pin that you could, shoved it into that hole, and basically you derive the axis from that gauge pin, and you're trying to figure out what the diameter of that theoretical cylindrical tolerance zone is based on the axis of that gauge pin. Now, what I've seen in the past is that some guys will use their CMM probe and just probe one edge of the circle, typically the top surface, and totally ignore the other end or the entire surface. So what's that really mean? That just means that when you try to bolt these two parts together, your hole can be maybe 30-40 degrees going in the other direction, and when you put a bolt through it, it's not going to go through. There's a lot of fundamental rules that one typically has to follow, but some of these CMM softwares, they kind of let you get away with using maybe a cross section or maybe a circle of a hole. Typically, if you guys are frustrated, that's sort of the reason. You really need, like I said, Gd&T is an international language, and it really needs to be understood from many disciplines of engineering. Like I said, you need design. They really need to know it. Your manufacturing guys need to know it so that they can understand, well, what type of tools do we have to use to meet these tolerances. Your quality guys, the guys that are inspecting, they need to understand. It needs to be understood at all levels. And what I've seen is that, hey, it's mainly used in a certain segment or certain discipline of engineering, but not all. Basically, it needs to be understood throughout. Remember, if you guys go to like a different country, and let's say you want to speak, let's say Russian. Russian is not only spoken by the middle class, it's spoken by the upper class and the lower class, right? You don't just say, oh, well, I want to speak Russian to the upper class and use sign language for the middle and the lower class. No, it needs to be used throughout. That way you guys can have a successful product line and things that go together. And at the end of the day, you guys are making profit and everyone's happy. Remember, the manufacturing industry is about 10-15% margin. You don't want to screw it up somewhere in the process of manufacturing, right? You don't want to have an awesome design, but it gets screwed up because someone's not inspecting it correctly. So once again, I just want to just say that for today's topic. I'd like for you guys to hit the like button, hit the subscribe, tell your friends about it, and you can visit my YouTube channel at www.gdtology.com. Thank you.